Okay, Assalamualaikum and very good afternoon. Okay, so basically today I just record this lecture so that you can have some revision on your own lah. Okay, due to your apa ni cuti Deepavali. Okay, so basically for today's lecture it will be immobilized enzyme based bioreactor. Okay. So we go to what is immobilization is all about. Okay, I think from our previous lecture, last 2 week lecture, I already explained what is immobilization. So this is only a recap. Okay, so immobilize means we call it make the enzyme to become unable to move at its own. Okay, so how? By entrap or fix them on certain supporting material. Okay, but when you can use immobilization methods. Okay, so basically the enzyme can be immobilized when the reaction is only a single step. It means that the enzyme is only um, convert one process only. It means it will convert one substrate into one simple products only. Okay, and then number two, there is no need of any coenzyme. It means that there is only one enzyme being used. Okay, and also no coenzyme is being added. Okay, why? Because if you have lots of different kind of enzyme being immobilized into a support material, it will reduce the yield of the product and it is difficult for purification methods after later. Okay. Next, what is an immobilized enzyme-based bioreactor? Okay, so bioreactor that have immobilized enzyme is actually, it means that you have one enzyme, okay, and then you use that enzyme, you immobilize it into any support material. Some other you encapsulate it or make a bead, okay, and then you put it inside the reactor at a specific location. Okay, so that is the meaning of enzyme-based bioreactor. So this immobilized enzyme can be used in a continuous flow. Okay, it means that you will flow in a reactant inside. Okay, and then there are the reaction of the reactant will be catalyzed by that particular immobilized enzyme inside that bioreactor lah. Okay, so this is a simple advantages of immobilized compared to free enzyme is actually it increase stability. It can be used or recycled a few times, and the separation is easier compared to free enzyme. Okay, so this is the thing that you need to consider when you want to design a immobilized bioreactor. Okay, first of all, you need to consider the mass transfer. You need to consider when you encapsulate your enzyme, the membrane of your support material may able to transport or the oxygen can pass through your membrane of your supporting material or your beads, and also there is a tendency for gas to be removed. Itu adalah, that one is the first criteria. The second one is the nature of the substrate and also particle characteristic itself. Okay, so for third temperature, the damage of the cell membrane is greater lah compared to pet bed. Okay, so if you want to use immobilized enzyme, you need to make sure if you want to immobilize your enzyme inside a third time reactor, you need to make sure that the immobilized enzyme is resist to shear stress. Okay. Second, the third one is kinetic consideration. Kinetic means you need to consider the rate of product formation and also the rate of substrate utilization. Okay, and then the fourth one, the growth behavior of the cell. Okay, this is when is the lag phase of your cell, when is the log phase of your cell, when is the exponential phase. That one you need to consider as well. It means that you need to focus on that one. How long it takes for an optimum enzyme activity. Okay, and also the immobilization method lah. Okay, as you know, I think from your previous slide, you already know that immobilization method it have passive and also active immobilization methods. Okay, so this is the current application of immobilized microbial cell. You have example here. I put production of L-aspartic acid, L-malic acid, L-alanine, and so forth. Okay, so if you want to know more about this one, you can search for this application lah. Okay. Next, we go to methods of immobilization. Okay, for methods of immobilization, you have, as I said, active and passive. Okay, so the differences between active and passive, if active, you need to add some chemical reagent, to help it to form a cross link, to form a covalent bonding, and also to entrap the gel, entrap the cell into the gel. Okay, but for passive immobilization, it means that you just let it to form a flock or cell naturally, and it will be attached to your cell secara natural lah. Okay, according to electrostatic interaction. Okay, so we go one by one lah. Okay. Okay, the first one is covalent bonding. Okay, I put example here. So the round one is actually your cell. So this is your cell. So the coupling ni, you need to add some coupling agent. Okay, example here I put polyisocyanate and also carbodiamide. Okay, so this one will form a linkage between these two cells. Okay, so the one that bind kat sini, selalunya usually the functional group that take part in this binding is amino acid group, hydroxy group, and thiol group. Okay, so the advantages of this bonding or this type of immobilization, it is free of diffusion limitation and it's stable for long period. Why is stable? Because the bonding here is stable. Okay, but the disadvantages, it might, okay, kat sini tulis, it might have a severe damage to the enzyme activity because this is cell. Okay, usually enzyme or biocatalyst. So if you put something here, it might cause a damage to the activity or it will reduce the activity, and also sometimes it is a complex to prepare. Okay. Okay, the second one of active immobilization method is physical entrapment. Okay. Sorry. Okay, so the entropy method is based on the occlusion of cell within the lattice of a polymer matrix. Okay, kalau kamu tengok ke sini, this is a polymer matrix. Okay, so this polymer will entrap your cell. The blue one, the yellow one is your cell, so it will entrap here. It does not bind, so there is no tendency for your cell to be rosak lah ataupun rupture or anything. It is only bind inside. Same goes to here. This is encapsulated into semi-permeable membrane. Okay. Okay. So the advantage is simple. It can have different pore size, and also the condition to prepare is biasa saja. Okay. But the limitation, the cell tu might pecah in your gel. Okay. So if it pecah or anything happen, free radical might be formed. So this free radical ni might become toxic to the process. Okay. So this example of entrapping material, you have synthetic polymer. So this polymer is usually being used as a as the entrapping material. Okay. Next, we go to passive immobilization. We have two. The first one is adsorption. Okay, for adsorption, it is based on electrostatic interaction. Okay, as you see here, enzyme is negatively charged. The support material is positively charged. So because of the different charge, it will be attracted to each other. So it will absorb to each other. Okay. Another one, it based on the actual zeta potential. Okay, zeta potential means the degree of electrostatic repulsion between adjacent cell. Okay, sel yang berada dekat bila have the different kind of electrostatic repulsion, it will be attract or it will be attached to each other. It depends on the electrostatic charge. Okay, so that's how the absorption occurs. So for this absorption, it is a passive immobilization method. So it takes time to ready lah for this kind of immobilization cell. Okay, the second one is colonization. For this technique, it actually the cell is actually become um, what we call it, attached to a matrix support material. It will colonize. It will colonize on this support material. So this the membrane here is actually a porous structure lah. So dia akan attach to each other. Dia akan macam attach to the surface of the cell. Okay. Okay. So this advantages of this immobilization method of BSP ni, absorption process ni, is actually no chemical addition. Okay, no need for pre-production because it actually attached to each other. It easier to handle lah, no aseptic handling. And then mass transfer rate is higher. Why? Because it is colonized on the support material space. Okay, it can be reused. And this one is the best one lah. It is actually can stand to mechanical shear. So if you want to use immobilized cell inside a continuous tank bioreactor, you can use this kind of immobilized method. Okay, easy to scale up and the cost is got low compared to active because no chemical agent is required. Okay, so this is example of PSP for microbial cell, for animal cell, and also plant cell. Okay, you can download all this paper and read on your own to know more about this application. Okay, so this example of colonization. You can see that the apa ni, the dark one is actually the cell that being colonized on the support material yang color putih tu. Same goes to here. So this is example of chinensis bacteria that form a film dance on the surface of PSP. Okay, this is more example of biocatalyst for biofuel production. You can see lots of enzyme here attached to the BSP. Okay, here as well. Succinyloids immobilized on polyester. So this is the support material. So your membrane is attached to it using colonization methods. Okay. Okay. Tadi immobilization methods, passive and active. Now we go to different application of immobilized enzyme based bioreactor. Okay, for this immobilized enzyme, the usage or the application of it is wide. Okay, the first one you can go for food industry. Usually, example of food industry that are using immobilized enzyme based bioreactor is in production of high fructose corn syrup. Okay, for this kind of food, usually they will add some enzyme that are immobilized inside to increase the production of high fructose corn syrup. Okay. Number two, in pharmaceutical industry, in order to produce amino acid, immobilized enzyme being used inside the bioreactor, so it will produce lots of amino acid which are used in the production of antibiotic and also anti-cancer drug. Okay. The third one is for biofuel. This enzyme usually are being used to hydrolyze biomass such as cellulose and also semicellulose into simple sugar. So this simple sugar will be used as a reactant and it will be fermented into ethanol. Okay. Ini example lah. Okay, so what is the advantages of using this kind of immobilized enzyme-based bioreactor? The first one, of course, stability. So the stability of this kind of enzyme compared to free enzyme, we can see because it is protected from denaturation and also proteolysis. Okay, once you have your enzyme, okay, it is being entrapped into some gel or it is being attached into something, and some enzyme is already linked into each other, so that it is more stable. It is being protected from denaturation. Okay, so it is in terms of stability, and then greater reusability. Why it is greater in reusability? Because it can be used a few times without losing its activity. So this reduces the need for the enzyme to be replenished or increase the efficiency of the bioreactor. Okay, number 3, easier separation. Of course, it is easy to be separated. Why? Because they are attached to support materials. Ini dia attached to support material. So the enzyme will convert the reactant into a product without the enzyme being moved freely in the broth. So there is no need for you to separate the enzyme with the product. Okay, so easy to separate, or the downstream processing is limited lah, or at minimal punya requirement. Okay, higher concentration of enzyme. Sorry. Why higher concentration of enzyme compared to free enzyme? Because the rate and efficiency of it can be controlled. Because you can use higher concentration of enzyme compared to free enzyme. So, example, if you are using packed bag enzyme, the enzyme is being packed dalam satu bag. Okay, greater control over reaction condition. How? Okay, because immobilized enzyme can be used in a continuous flow system, which allow for greater control over the reaction condition. So this can lead to more efficient and consistent result, okay, and lower risk of contamination because it is attached to support material, so it reduces the risk of product rejection due to contamination. Okay, understand lah. Okay, so this is only the recap back. You have enzyme. This is a method for immobilization. You have adsorption, cross-linking, covalent bonding, and also entrapment. Okay. Next, we go to reactor configuration. Okay, so you have different kind of immobilized cell punya method, and also you have unit for the bioreactor configuration. It also divided into several criteria lah, category. Okay, the first one is the tank reactor, fixed bed, and fluidized bed. Fluidized bed is actually based on the pattern. The tank, of course, you have the impeller. Fixed bed means that you fix the bed, sama ada at the bottom of your bioreactor or at the top. Okay. Okay, so this is an example. The first one, A, is actually a stirred tank. So this is a stirred tank. So for stirred tank, this is the immobilized cell. Yang bulat-bulat ni, this is your immobilized cell. Okay. So for this case, you need to make sure that when you choose the immobilized cell must be resistant to the movement of this impeller. If not, it will burst, dia akan pecah. Okay, second one is fixed bed. Fixed bed, as I said, you fixkan dia, you tetapkan dia kat mana dia nak letak you punya beds. So this is your bed. So the immobilized cell will be arranged in the bed accordingly lah. Okay, so the flow come from the bottom and then flow to the up, or from the top to the bottom. Okay, the last one is immobilized cell on the fluidized bed. Fluidized mean the cell move freely, tapi dia bukan free enzyme. The cell yang already being immobilized will move freely inside this bioreactor. Okay. Okay, we go to the first one, stirred bioreactor. Advantage, easy to control the pH, temperature, and also mixing is perfect lah. Okay, but then the disadvantages, immobilized cell might be exposed to high degree of shear. So bila dia terlalu exposed to shear, and because of the shear stress, the cell might be pecah or ruptured or damaged. Okay, fits back mean you fix the bag or you pack it. Okay, so the advantages is might be the bag porosity. Saya tunjuk kat sini lah, senang nampak. Okay, so this is the fixed bag. This is your bioreactor, the column of bioreactor. So the bag will, the cell will, the immobilized cell, dia akan berada dalam this fixed bag. Dia tak bergerak and trap into a solid or adsorption. Dia akan remain here throughout the process. So the reactant will be purged from the bottom or might be from the up. And then you, kalau if the reactant is being purged from the bottom, flow from the bottom, your product will be collect here lah at the top. Okay. So this example of a fixed bag. You have different kind based on the flow. For this one, you have the bag. This is the bag, the catalyst or the bag of your mobilized cell. Okay. This is also. Okay, so you flow in liquid and gas from the bottom, from the upper layer, from the top layer of your column. Okay, so from the top it will be moved to the bottom. Okay, so you will collect your result here lah, your product here. Why it cause is a trickle? Trickle mean it will be spray. Dia bukan masuk secara banyak, dia akan spray slowly here. So the liquid will be moved daripada atas sampai ke bawah, from the top to the bottom. Why we call it co-current? Because the liquid and gas come from similar pot daripada atas. Okay. Second one is slurry phase reactor. The liquid come from the bottom. The gas will be also come from the bottom. And then you will collect the result, your product here at the top. So your catalyst is actually move freely inside. Okay. Number 3, trickle bed reactor. This is trickle bed, similar to the first one, but the flow is counter current. It means the liquid come from top, gas come from bottom. And it will be trickle also, spray also here. So the movement from liquid to the bottom, from top to the bottom, the gas from bottom to the top. Okay, so there is mass transfer here. Your cell will be here, immobilized cell will be here. Once the liquid come into contact with your cell, there is mass transfer change, means that the reactant will go pass through your bits, your membrane of your immobilized cell, and it will go inside your cell. Then the cell will take the reactant and as a substrate, and it will convert it into a product, and then the product will goes up and you will collect your product here. Okay, packed bubble flow, it is similar to all the first three. The immobilized cell will be in the pack here, dalam bentuk packing. The gas will be coming from the bottom. The liquid also will be coming from the bottom. Tapi dia ada bubble flow because of you add some bubble here. Okay, so this is the different kinds of feedback immobilized base bioreactor. Next, we go to fluidized bag. For fluidized, they don't have any packing. It only have immobilized cell that can move freely inside. Okay, you ada immobilized cell yang can move freely inside. You feed some oxygen from the bottom or any gases required, and then the movement of the gas tu yang akan make sure there are mixing of your immobilized cell inside. So it is easier to control, and also the measurement of pH and dissolved oxygen is easy. Okay. So the mixing is okay lah. Offer good mixing and also mass transfer based on the movement of the gas. Minimal pressure drop. Okay, compared to feedback dia punya pressure drop tu sangat might occur because of different density of the bag. Okay. I think itu saja for this lecture for you to understand. So hopefully you understand lah my explanation. If you have something that you not really understand, you can WhatsApp me personally or can come and ask me personally lah in my room. Okay. So next lecture will be animal cell bioreactor. So basically for today's lecture, you need to understand what is immobilized. Okay. And then you need to understand different kind of immobilization methods, and also you need to know some example of each immobilization methods. Okay, and then the thing that you need to consider when you want to when you want to design your immobilized base bioreactor, you have set tank, you have fluidized bed, you fluidize immobilized bioreactor, and also you have another one is pack ataupun fits back. Okay, so if you are able to differentiate the advantages and disadvantages of each of the different kind of bioreactor, I think it is good enough for you. But make sure you need to have the exact example lah, or the application of it. Okay, and that's all from me. Happy holiday. Thank you, everyone.